I bought this repossessed Bugatti Veyron with supposedly a broken gearbox. Nothing happens, but we managed to solve the problem with just a tiny fuse.
There are very few moments in automotive history where one single person's stubbornness changed the direction of an entire industry. The story of the Bugatti Veyron is one of those moments. It did not begin in an engineering lab or on a test track, or with a team of scientists sitting around a table drawing plans. It began in the mind of one man, Ferdinand Piëch, who decided that the word impossible did not apply to him. Piëch was not a person who set targets and then waited to see if his team could reach them. He was a person who decided what the outcome would be and then expected his engineers to figure out how to get there. That difference in thinking sounds small, but it meant everything for what the Veyron eventually became. By 1998, Piëch had already done things inside Volkswagen Group that many people considered impossible. He had turned Audi from a forgettable brand into one of the most respected car companies in the world. He had saved Porsche when it was struggling. He had bought Lamborghini and Bentley and brought them under the Volkswagen umbrella. And then in 1998, he acquired Bugatti, a name that had not made a serious car in many decades. Most executives in his position would have asked their team to study the market and figure out what kind of car would make sense. Piëch did not do that. He already knew what he wanted. He wanted a car that produced over 1,000 horsepower and could travel faster than 400 kilometers per hour. He wanted Bugatti to become the most extreme car company in the world, and he wanted it done no matter what it cost. When Piëch first told his engineers what he wanted, the original plan was even more extreme than what eventually got built. The first idea was an 18-cylinder engine. Just saying that number out loud tells you something about the kind of thinking going on in these meetings. An 18-cylinder engine would have been incredibly long, extremely heavy, and so difficult to manage thermally that putting it inside a road car would have been almost impossible. The engineers understood this immediately. They did not tell Piëch it could not be done. That was not something you said to him. But they did manage to convince him to look at another option. That option was the W16 engine. The idea behind the W16 was clever. Volkswagen already made a compact engine called the VR8, which used a narrow-angle design that put its cylinders closer together than a traditional V8. Two of these VR8 engines were joined side by side to create a single unit with 16 cylinders arranged in a W shape. The result was an engine that was wider than a traditional V8, but shorter than a straight 8, and it produced a firing pattern and a balance that no normal engine layout could match. On paper, it had a clear path to the kind of power numbers Piëch was asking for. But the W16 was not a known quantity. Nobody had built one before. Nobody had run one in a car before. Nobody knew for certain how it would behave under full load, or at extreme temperatures, or after 1,000 kilometers of hard driving. The engineers were not selecting an engine from a list of proven options. They were inventing something entirely new and then hoping it would work the way they needed it to. For turbochargers were added to the design to push the power output toward the 1,000 horsepower Mark Piëch demanded. Each one of those turbochargers added heat, complexity, and pressure to a system that was already operating at the very edge of what materials could survive. This was not engineering an existing idea further. This was building a new idea from nothing. Once the decision to use the W16 with 4 turbochargers was made, the engineers immediately ran into the first of many walls. Heat. An engine of this size and this power output generates a staggering amount of thermal energy. In simple terms, it gets extremely hot, extremely fast. If that heat is not removed from the engine quickly and efficiently, the engine destroys itself. Every car has a cooling system for exactly this reason, but the cooling system on a normal car is designed for a normal engine. The Veyron's engine was not normal in any sense. The cooling requirements were so far beyond anything that existed in any road car that the engineers essentially had to design a cooling system from scratch. What they came up with was not elegant. It was not simple. It was a result of years of testing, failing, adjusting, and testing again. The final solution involved 10 separate radiators spread across the body of the car. 3 of them sat at the front and handled the engine's main water circuit, which carried 40 liters of coolant constantly circulating through the engine. Another separate circuit, operating at a lower temperature, handle the air that came out of the turbochargers, because that air gets extremely hot when it is compressed and needs to be cooled down before it enters the engine. This second circuit carried another 20 liters of coolant. In total, the Veyron contained 60 liters of coolant flowing through its systems at all times. To put that in perspective, many normal road cars carry less than 60 liters of fuel in their tanks. The Veyron carried more cooling fluid than most cars carry petrol, moving all of that liquid through the car's body while managing the pressure, the weight, and the temperature differences between different parts of the system took years of development work on its own. And here's a remarkable thing about that achievement. As extraordinary as the cooling system was, it was not even close to being the hardest problem the engineers had to solve at IN 2001. Roughly 3 years into Veyron's development, the engineers began trying to find tires for the car. This sounds like it should be a simple task. You build a car, you call a tire company, you order tires. But what the Bugatti engineers discovered when they started making those calls was something that stopped the entire program in its tracks. The tires they needed did not exist. No tire company in the world made a tire that could safely support a car traveling at 400 kilometers per hour. This was not a problem of supply or cost or delivery time. It was a physics problem. At 400 kilometers per hour, the wheels of a car are spinning at an almost unimaginable speed. The centrifugal force trying to pull the tire apart from the inside is enormous. The heat building up inside the rubber from friction and flexing is extreme. The forces pressing down on the contact patch between the tire and the road are massive. No rubber compound, no internal structure, no bead system. The part that holds the tire onto the wheel existed anywhere in the consumer or performance world that could handle all those things at once at that speed. Bugatti turned to Michelin, one of the most respected tire companies in the world, and essentially handed them a problem nobody had ever been asked to solve before. Michelin accepted and began a development program that ran for 5 years. 5 years of research, testing, compound development, structural engineering, and failure analysis just to produce a set of tires for one car. What eventually emerged was called the PX run-flat system. It used a rigid ring mounted to the inside of the wheel that would support the car's weight even if the tire itself lost pressure at speed. Because at 400 kilometers per hour, a sudden tire blowout would be fatal. The rubber compound and the internal structure of the tire were engineered specifically for Veyron speeds using reinforcement technologies that existed in no other tire on the market. The development cost was enormous, and Michelin passed that cost directly to Bugatti, who passed it directly to the buyer. A set of 4 Veyron tires cost approximately $42,000. Not the wheels, just the tires. And those tires needed to be replaced every 2,500 miles. Not 40,000 miles like a normal performance tire, but 2,500 miles, because the stresses they operated under wore them out that fast. There is one specific detail buried in the Veyron's tire specification that captures the true strangeness of this machine better than almost anything else. At full top speed, 407 kilometers per hour, the Veyron's tires have a functional life of approximately 15 minutes. That means that after 15 minutes of driving at maximum speed, the tires begin to structurally break down. Despite everything Michelin's engineers achieved over 5 years of development, the rubber and the internal structure simply cannot survive the accumulated heat and centrifugal force beyond that point. 15 minutes before failure. That sounds alarming, and it is alarming, but the story does not end there. At full throttle, the Veyron's fuel tank empties in approximately 12 minutes. The car runs out of petrol before the tires begin to fail. The engineering limit of the Veyron was not the tires. It was the fuel capacity. Bugatti had built a car that was faster than its own ability to feed itself. The tires were designed to survive 15 minutes at top speed, and the engineers were confident in that figure. But it almost did not matter because no one would ever get close to finding out. And if a tire did fail, or simply reach the end of its 2,500-mile service interval, replacing it was not a matter of driving to the nearest garage. The PX system required specialized equipment that existed only at designated Michelin service centers. For most Veyron owners, the nearest center was in France. The service cost, not including the price of the new tires, was approximately $70,000 per visit. This was not information that Bugatti hid from buyers. It was in the ownership documents. But the fact that buyers accepted these conditions without complaint says everything you need to know about who was buying this car and what owning it meant to them. For the people writing checks for a 1.2 million euro car, a $70,000 service bill was not really a financial concern. It was simply the cost of being part of an exclusive group that owned something nobody else in the world could have. While the tire story gets most of the attention when people talk about Veyron engineering, there was another problem that deserved far more recognition than it typically receives. The gearbox. The W16 engine produced a level of torque, the rotational force that actually pushes a car forward, that no existing gearbox in the world could survive. Torque is what destroys transmissions. The more of it you push through a gearbox, the stronger and tougher that gearbox needs to be. And the Veyron's W16, with 4 turbochargers helping it breathe, produced more torque than any road car gearbox had ever been designed to handle. Every transmission available on the market was evaluated and rejected. None of them were strong enough. So Bugatti partnered with a British engineering firm called Ricardo, which specialized in complex drivetrain solutions, and together they developed a 7-speed dual-clutch gearbox entirely from scratch. A dual-clutch transmission works by having 2 separate clutches that alternate between gears, allowing shifts to happen almost instantly without interrupting the flow of power from the engine to the wheels. The system Ricardo and Bugatti developed was the first of its kind ever built to survive at the Veyron's torque level. At the time it was completed, it was widely considered the single most sophisticated road car transmission ever made. It was a genuine world first. And in the broader story of the Veyron's development, it is barely a footnote. That one fact, that a world-first transmission is not even a headline achievement in the context of this car, tells you more about how extreme the Veyron project was in almost any single specification. The engineering was so dense, so layered, so full of genuine firsts, that one of the most advanced gearboxes ever built for a road car barely registers as a notable detail. The Veyron went on sale in 2005 at a price of approximately 1.2 million euros. That number sounds extraordinary in the context of everyday life. For most people on Earth, it represents more money than they will earn in several lifetimes. But in the context of what the Veyron actually cost Volkswagen Group to build, it was nowhere near enough. Analysts at Bernstein Research, a well-respected automotive research firm, estimated that Volkswagen Group lost approximately 6.25 million euros on every single Veyron it sold. The car sold for 1.2 million euros and cost more than 6 million euros to produce. Multiplied across the full production run of 450 cars, the total estimated loss for the program was approximately 1.6 billion US dollars. That is not a rounding error. That is not a financial model with loose assumptions. That is one of the most significant financial commitments ever made by a car company for a single model, and the books never came close to balancing. To understand why Volkswagen Group, a publicly traded company answerable to shareholders and board members, would willingly absorb that kind of loss, you have to understand what Peach was actually trying to accomplish. In 1998, when he acquired Bugatti, Volkswagen Group was spending enormous amounts of money on luxury and performance brands. They had spent around $700 million in a very public battle to acquire Rolls-Royce and Bentley. They had spent hundreds of millions more stabilizing Lamborghini. The VW board was not a group of cautious, conservative financial managers. They were people accustomed to making bold, expensive statements about where the group was going. But even by their standards, the Veyron's development costs were alarming. There was genuine opposition inside the company. Board members questioned openly whether a car that cost more than 6 times its sale price to build could ever be justified on any balance sheet. Peach's answer to those critics was not a financial argument. It was a strategic one, and time proved him correct. In 2005, the year the Veyron launched publicly at the Frankfurt Motor Show, Volkswagen Group's reputation among the wealthiest car buyers in the world was measurably behind that of Ferrari and Porsche. Those two brands had decades of heritage, racing success, and cultural status that money alone could not simply buy. Peach understood this. He also understood that the only way to close that gap quickly, not over decades of gradual brand building, but quickly, was to do something so dramatic, so publicly impossible, that the automotive world had no choice but to acknowledge it. The Veyron was that something. By 2010, 5 years after launch, Bugatti had become the default reference point for anyone in the world who wanted to describe the ceiling of what a road car could do. Journalists used it. Buyers used it. Other manufacturers used it when they were setting their own performance targets. That shift in perception did not come from advertising. It did not come from a marketing campaign or a celebrity endorsement or a cleverly written press release. It came entirely from one car that proved a point so completely and so publicly that there was simply no arguing with it. There is a moment in this financial story that makes the strategy even clearer in hindsight. In 2008, 3 years into the Veyron production run, the global financial crisis hit. Luxury goods markets collapsed. Ultra-wealthy buyers who had been spending freely suddenly became cautious. Manufacturers of expensive cars were cutting their production targets and negotiating with dealers over unsold cars sitting in showrooms. Bugatti sold every single Veyron allocated for that model year. The waiting list held firm. While the rest of the luxury automotive market was suffering, the Veyron was immune, not because its buyers were financially unaffected by the crisis. Some of them certainly were, but because the Veyron had become something that transcended its function as a vehicle. It had become a cultural object, a statement of wealth so extreme that the act of buying one did not register as a financial decision at all. A person who could spend 1.2 million euros on a car during a global recession was not thinking about resale values or market conditions. They were buying a place in history that it is important to spend a moment thinking about what Peach himself represented, because without understanding him as a person, the Veyron story does not fully make sense. Peach was not building the Veyron because he thought it would be good for Volkswagen's quarterly earnings. He was not building it because a market research report told him there was demand for a 1,000 horsepower car. He was building it because he thought in terms of legacy, not in terms of financial cycles. His personal history was intertwined with engineering ambition at the highest level. He came from the Porsche family. His grandfather was Ferdinand Porsche, who designed the original Volkswagen Beetle and later founded the Porsche company. Engineering excellence was not just a professional value for Peach. It was a personal identity. The Veyron was, in the most honest reading of the evidence, a personal declaration. It was Peach saying to the automotive world, in the most public and permanent way possible, that Volkswagen Group was capable of things no other company could match. The $1.6 billion loss was not a mistake or an oversight. It was the price of the declaration. It was the cost of making a statement so clearly and so permanently that it could never be taken back. Whether that was the most admirable or the most reckless use of shareholder money that any automotive executive has ever made is genuinely a matter of perspective. The answer depends entirely on whether you think the value of what the Veyron proved to the world is worth $1.6 billion. Many people in the industry, looking back now, believe it was worth every cent. The brand value Bugatti gained, the engineering knowledge that was developed, and the foundation it built for everything that came after suggests that the return, measured in the right way, was actually very significant. By 2010, the Veyron had been in production for 5 years. In that time, Bugatti had introduced the Super Sport variant, which pushed the engine output from 1,001 horsepower to 1,200 horsepower. They had also introduced open-top roadster versions that proved the architecture could work without a fixed roof. The car was evolving, and each new version pushed a little